Hello and welcome back. So in our previous segment we talked about what the Coriolis force was. And it's an optical illusion that it appears that winds are bent to the right in the northern hemisphere. But what's really happening is winds are blowing in a straight line, but the Earth is rotating out from underneath them, so it appears that they're bending to the right. So what we want to do is apply that to the Earth and find out what does it make the wind systems do. Okay, so we want to look at this from two different perspectives. One is going to be the side view, and one is going to be the top-down view. So that if we were to make a big picture of the Earth, then the equator, which is going to have 0 degrees latitude, is going to be at the equator. That's going to be the hot part. So from the side view, air is going to rise in the troposphere until it gets to the stratosphere, and then it's got to go someplace because there's more material coming right up underneath it. So what's going to happen is this air is going to want to go someplace that is cooler. And so it would travel to the North Pole, and then it would come back down again because there's more material coming up from behind it. Now it's got to go somewhere, so what it would do is it would return back to the equator, so that you would have a gigantic convection cell, and then that convection cell would wrap completely around the Earth, and then you'd have another convection cell down here, which I won't draw, but it'll be the same deal, that air is going to rise, and then it would move to the South Pole, and then it would come down, and then it would return to the equator. Okay, so that is what the winds would do if the Earth was not rotating. So let's look at it from a top-down view. So that in the stratosphere, it's moving north. So the winds in the stratosphere would move from south to north. And then the surface winds, okay, now look at the surface, it's going back to the equator, so the surface winds would blow from north to south. Now what we want to do, though, is we want to allow the Earth to begin to rotate, and we want to see what's going to happen. So the air is still going to rise at the equator, and it's still going to start to travel to the North Pole. So again, this line over here is this line right here. But because of the rotation of the Earth, this wind system is going to turn in that direction, turn to the right. And eventually it's going to turn so much to the right it can't go north anymore, and so it's going to run out of gas, so to speak, and it's just going to give up, and it's going to start going south back to the equator. But the problem, though, is it's going to turn to the right because of the Coriolis effect. So again, it's going to loop like that, and then it starts its journey all over again. Up in the stratosphere, it starts to go north, turns to the right, gives up, comes back down to the Earth's surface, and then starts going like that. So from the side view, this is what it's going to look like. It goes up, goes north, gives up, comes down, and then goes back to the equator. So that you have this big convection cell has been turned into a little convection cell right there. So what happens up here? Well, it turns out that everything gets reversed, and you end up with another convection cell that is going to do this. Like that. So now you've got another convection cell up there. And if you look on the picture there, again, you can see how that red arrow is constantly either being bent to the right or being or going to the Well, it's always going to be going to the right because of the Coriolis effect, but you see it kind of changes direction as you go from one convection cell to the next one. And then there's a third convection cell up here, and it's going to be going up here, and then it's going to go north. It's going to come down just like it did before, and it's going to go this way until it gets to here, and then it goes back up again. So because of the rotation of the Earth, one convection cell on the top and one convection cell on the bottom has been turned into 3 on the top and then 3 on the bottom. And I know you're saying, well, who cares? So, you know, winds get knocked off course. What difference does it make? Okay, now let's combine this information with what we know about cloud formation. So with clouds, they rise into the air because they're under what kind of a pressure system? Clouds form under low pressure systems. So when the air can rise, that's a low pressure system, and then that allows clouds to form. But when it's coming down like this, that's a high pressure system, and you don't get clouds. So where on this picture here would you have clouds, and where would you not? Okay, you'd have clouds where it's going up. So look here, the air is going up right here. So you're going to have lots of clouds at the equator and lots of rain. Now, can you spot a place where the arrows are going down? That would be right here. So right here is going to be a high pressure area, no clouds. And then that corresponds to about 30 degrees latitude. So where is 30 degrees latitude? Well, it's approximately the border between the United States and Mexico. So what's the climate like at the border between the United States and Mexico? It's like a desert is there. Very dry. And that's because it's constantly under a high pressure system. So your major deserts are going to occur at 30 degrees latitude. Now, let's go up a little bit further to 60 degrees latitude. So here's 0, 30. Where would 60 be? Well, 60 would be right here. And notice that the air is going up and the air is going up. So again, you're going to have clouds that are going to be right there. So it's going to rain at the U.S.-Canadian border, but at the U.S.-Mexican border, it's pretty much deserts. If you take this across the Atlantic Ocean, so 30 degrees, take it across the Atlantic Ocean, you end up in the Sahara Desert of Africa. So at 30 degrees, you tend to have your major desert systems. Same thing down here. So at negative 30 degrees latitude, you also tend to have deserts. But you have rain at the equator and at 60 degrees. Okay, let's go on here and talk about that not only does it affect the surface winds, but as those winds blow across the ocean, it causes the surface ocean to start to move around. So you have surface ocean currents as a result of the surface wind patterns. And so we're not going to get into it, but you can learn about, for example, the trade winds, and then how did the trade winds cause the Gulf Stream and things like that to occur. But I just want you to see that the wind systems can affect the ocean currents as well. Okay, let's look at one more thing before we take another break, and that is what happens in between the convection cells. So here, in between this convection cell and this convection cell, the winds are very turbulent because you either have stuff going up or stuff going down, and it gets very mixed up in that region. So you're going to have regions of unusually high winds in between these convection cells, and we're going to call those jet streams. So that you have the what's referred to as the subtropical jet stream, which occurs at about 30 degrees latitude, and then you're going to have the polar jet stream that occurs up at about 60 degrees latitude. Now they don't go sideways, so they kind of act like a river, which means that sometimes they kind of dip down and then sometimes they go up again, but on average they're hovering around 30 and 60 degrees latitude. Now why are these important? Because they steer high and low pressure systems, get caught up in the jet stream, and then they can be pushed across the continents. And same thing for cold weather and warm weather patterns can also be steered by the jet streams. So here in Missouri, we're more interested in the polar jet stream. But if you live in California, Los Angeles, you're going to be more interested in the subtropical jet stream and what it can do. All right, so in our final segment, we're going to start talking about reasons for climate change. So I'll see you in just a moment.